Welcome back to another construct video, and in this video I'll be doing a full breakdown of my Minecraft skyblock map, which I made a video about a couple of days ago. So this will be a much longer video and we'll be going into all the details about the code so you can start seeing how stuff like the 3D mouse cursor works, how the inventory system works, how breaking blocks work, all that stuff. We'll go through it in this video. So it's going to be a much longer video than you're normally used to on my channel, so strap in and let's go through it. First thing we should talk about is the island itself. This island is just created by hand, so I've created a load of 3D blocks. So most of these I just looked and got the sprites off a texture pack, and each face is just the different faces of the block. Once these were done, I just put them in using a grid that was on 64 to move them into the correct place, and I hand built this island using all those blocks. So there's no code to get this island created, it's all hand built. The second thing that you'll notice if we move up and across is the inventory system. This is actually in the viewport, so we can actually zoom in and see that a bit more. And I'll explain this a little bit more when we get into the code of this and how this works. But yes, this is in the viewport, so we're able to see it using a parallax layout. So let's go to our main code. Now, for our main code, we're only able to attach one event sheet. As you can see, I've got quite a few different event sheets. So easiest way around this is attach a main event sheet, and then you can right click and include event sheets. And I've just included all of them from the other parts, so it just means I can separate my code out and make it a little bit neater. Next thing we're actually going to look at is the day-night cycle, because this is very separate to all the other bits of code. It doesn't link to any bits of code, so it's a good one to look at first. So first of all, I've got a variable called time of day. This starts at 0, and every second I'm going to increase that value by 1. And this just allows me to check at what point is it day, what point is it night, how long it is till day and night if I was to take this project further. And the moment it gets to 300, we set it back to 0. 300 works about 5 minutes. So it's on a 5-minute cycle. Once it gets to the end, it goes back to the start again. Now we've got these values, we can actually use them. So the first time it's used is checking if the time of day is between 1 and 10. If it is, we're going to take these 3 channels here. Now these are set to what the default sky color is, and I'm just adding to these 3 values by a certain amount. Bear in mind that this is morning, so these values will be quite low, and we're slowly increasing those values up to these numbers that I want them to be. So the red will probably be around about 20, and we're slowly increasing it to 179, 0.6 at a time. Green will increase from 226 from its lower value by 0.8 at a time, and blue will take its low value and increase by 1 each time until it reaches 255. You'll notice I'm increasing blue and green more than red, and that's just because I want the blue and green elements to come through more in the sky as we're doing that transition. Every tick of doing this, I'm also applying these colors back into the background, so we get this smooth transition from a very, very dark night sky to the light blue that we begin with. Once we also get this bit of code working, I'm also going to make sure the sun becomes visible. I'm going to set Z elevation to 200, and then as the code goes on, as the time of day goes on, you'll see that I'm actually moving my sun up into the sky. If my time of day is between 140 and 150, we do the opposite. We subtract these values, subtracting more from red and green and not as much from blue. And again, this means it slowly goes dark, but because the blue channel is going slightly slower, we still get that blue color in the sky. All these values are clamped, so we can't go below a certain amount, so they can't all hit 0, which will give us pitch black. We get a sort of dark bluish grey instead. And once again, the sun will disappear and the moon will become visible. So it's a really simple day-night cycle, and this is something you can easily implement into a 2D game as well as a 3D game. Let's move on to some of the more complex stuff then in this engine. So we're going to move on to the block interactions, and this is all the things to do with breaking and placing blocks and our 3D mouse cursor. I'll start with the cloud logic. It's really, really simple. I'm just spawning 100 clouds and just put them in the random positions and random elevations. Don't really want to spend too long on that because it's not too difficult. It's something you can look at and put together. However, the 3D mouse cursor is something that is far more interesting. So the 3D mouse cursor takes the mouse's position on the screen and it moves this box around. Now, I'm using this method called round, and I'm dividing whatever the mouse is by 64 and times it by 64 again. By using the round function with this, it just means that it will find the nearest value of 64 and place it there. And obviously our game works in block size of 64, which means it's moving in a square format, which is what we want. So that controls our X and Y, but we also need to control our Z elevation for looking up and down. Now we can't take the mouse position because the mouse position is on a 2D screen. So what we do instead is use the camera rotation on the Y axis. So this is where you use the mouse to look up or look down, and we're using that to sort out the Z elevation for the mouse select. Once again, we're rounding that number to give it in 64 implements. So that's that done. However, when this was implemented, the mouse selector used to be miles out in the distance. I wanted to bring it much closer to the player so it was only in the space you could interact with. And this is where the second bit comes in. This is a lead. And I've used this concept before when I was using thumbsticks for a 3D game. And it works exactly the same. You've got a lead that's attached to the player and attached to the mouse select. This lead can only go to 256. So if the mouse select goes beyond 256, we teleport the mouse select to the end of the lead and we stop it going any further. So this is a really, really simple method to allow us to have a really rounded box around the player on where they can actually look. And by reducing this back, it actually makes it easier to select the block you want because you can't select the blocks out in the distance. You can only select the blocks close to you. Next thing that we've got is we've got the break block. So in order to break blocks, we've actually got an animation. I'll talk about how we break blocks in a second. But as we're breaking blocks, we have this animation set. So I'm just changing each face to this animation called block break cursor. And this just goes to 4 animation frames from a slightly small crack to a bigger crack to a really big crack. And actually, if I go into my options here, we can actually look at the animation for that. So that's in the cursor. And we've got these 4 animation frames that it goes through to show that breaking effect. And that happens on all 6 faces. Now, I'm applying a parameter here called time to break. This will come from the block data we'll talk about a little bit later. So because there's 4 animation frames, we take 4 divided by the time to break. And this means even if it's something that takes 20 seconds to break, the animation will still play all the way through, as opposed to something that will take 0.5 seconds to break. I've also got a function for the idle cursor, which means once we finish breaking something, we can just bring the cursor back to normal. So that's the 3D cursor. Let's move on to actually how we're using that to break blocks. So the first thing I'm checking for is, are you holding the left button down? Obviously, this is my button I'm using to click. And I'm also checking if you've got the pointer lock, because if you're not, you're probably in an inventory. And we don't want you to be able to break blocks if you're in the inventory. And then we're checking if the block's X position equals the mouse select X position. So is the X position of where the mouse cursor currently is that the same as a block's X position? Bear in mind that the mouse selector and the blocks are all working off 64 pixel increments, which means that they would be exactly the same. Do that for both the X and the Y. So is the mouse cursor's X and Y the same as a block's X and Y? And is the Z elevation the same? If that's the same, it must mean that our mouse cursor is on top of a block. So now we can start a couple of things. So first of all, if the timer for block breaking is not running, then we need to start that timer. We're also then going to call the break cursor and have that running. And in terms of how long that's going to go for, we'll talk about that a little bit later because I'm getting a value from an array called blocks. The moment this time is finished, so let's say that it takes 1 second to break a block, we're then going to create an object. That object is actually going to be the drop item. So when we break a grass block, we'll have a tiny little grass block that spawns and spins around that we can pick up, that'll go into our inventory. We can then destroy the block and we can put our cursor back to idle. We'll explain more about the item drops a little bit later. If the left button's not down, we stop all timers for block breaking and we just put the cursor back to idle animation. So if you decide you don't want to break a block, you let go of the left mouse and everything resets back to the beginning. We then have the drops. Drops are those small items that fall on the ground when we break a block. I'm just checking if one of these has been created, and what we're going to do is set the position to where it spawned And then I'm just adding a randomness of about 8 pixels each side of it on the X and the Y. So if you break lots and lots of items in the same area, they won't be stacked completely on top of each other. There'll be a little bit of a leeway between them. We're also going to make sure their Z elevation is set to where the block was, or in this case where the mouse select was. And then drop DZ, this is actually its gravity settings, which we'll talk about a little bit later. In terms of leaf blocks, I've got a slightly different thing that has a 1 in 5 random chance. So when a leaf block is destroyed, it will spawn a small leaf block. There's also a 1 in 5 chance it will spawn a sapling as well. So it's creating a block. And I'll talk about this block data again later on when we get to that stage. That's a really important part of how a lot of these systems work. In terms of placing blocks, same logic. We just check if the right click is made and has pointer lock. I'm then also going to check if the block cursor or the mouse cursor is got the same X, Y, and Z coordinates. If it has, then we can't place a block there because there's a block already exists. However, if that X, Y, and Z position is for a crafting table, then we can open the inventory. So that's how the crafting table works. We check if the mouse cursor is over it and we're pressing right click. The crafting table will open, and this is the same logic I'll use for the furnace. So I'd copy and paste this and change crafting for furnace. If this is not true, there's no block in that position, we can then move to this else statement. So this bit of code currently doesn't work, and this bit of code is designed to check if there is ground above, below, or next to where you want to place the blocks. You can't place blocks in thin air. At the moment, you can place blocks in thin air. But what it will do is create a block, and it will take the current block from your inventory, which we'll talk about a little bit later. And it will then take one item away from your inventory, and then this load hotbar is just a function that I've got that will refresh the hotbar so we can see what the new values are. So the main thing is we're creating a new object where the mouse selector is on its X and Y positions and its Z positions as well. So again, when the block's created, we need to move its Z coordinates up to the correct position. Then move on to drops then. So drops again are the thing that we pick up and full. So first thing that we've got here is drops. We subtract 0.001 from the drops DZ. This just means that they're going to fall really, really slowly downwards. Getting them to work so they land on top of a block has proved really, really tricky. And if I remember, I forgot to put it in my last video. I'll show you the bug that happens if we try and use the same logic we used to get the player to stay on the ground. It gives us some really, really weird issues. So for now, all I'm doing is making it slowly sink. This just means if you break something like a tree, you don't need to then climb up to grab the blocks from the top. They will slowly fall down, and it also stops a lot of lag because those blocks will eventually fall down outside the world and be destroyed. Now, this is the magnet that I've got. So what it's going to do is it's going to check the distance from the player. So this first bit is the Z elevation. So it's checking if the Z elevation is between the drops Z height minus the player's height, and this one's going to add the player's height, and I've also added a bit more leeway on the height being 32, so you've got around about 100 pixels worth of height. So if the player's in that sort of distance and the distance is 200 pixels away, then we're going to start getting the drops to move towards the player. The moment that we move out of there, we stop that. So this is what this else is doing, it's stopping that code. And this just means that if the player is near an item, the item will come to the player, which is the same sort of effect we get in the game. Now you'll notice that we've got the gravity situation. I'm just checking if the drops are above or below the player when the magnet's activated, and this will change the drops DZ from either 0.1 to minus 0.0, and it's going to falling down really, really slowly. They'll either fall down much faster towards the player, or they'll move upwards towards the player as well. So that magnet effect will deal with the Z elevation as well. We then do one more check to see if the player is overlapping the drops. Now, because Construct's a 2D engine, if you're overlapping the block, but the block's 10,000 pixels up in the Z elevation, you'd still pick it up, because it only checks, the overlapping logic only checks for X and Y positions, it doesn't check for Z. So I'm just checking if it's in this same range again of about 100 pixels and you're overlapping it. In that case, we're going to run this function called add item to inventory. Again, we'll talk about that when we talk about the inventory. And then we destroy the drop, so it's no longer there. Finally, I'm either going to load the hotbar or the inventory, depending on which one's open. And this is what this active layer is doing, checking if you've got your hotbar open or your inventory open. This comes down to our last two bits. We've talked about quite a lot of complex stuff. Let's talk about some really, really simple stuff instead. We'll start with the trees. So sapling on created. So this is when you place a sapling. It's then going to start a timer called tree. And it's going to be a random number between 20 and 120. So between 20 seconds and 2 minutes. The reason I've made this around that sort of time and not traditional Minecraft is this is a prototype. If I was making a full-fledged version and I got this finished, which I'm still planning to finish this, then I might up that timer. But for now, I don't want people to sit around ages waiting for trees to grow to test out this code. Once that timer then goes off, so after 20 seconds, 90 seconds, 120 seconds, we're then just going to create a wood block. Wood block will be created at the base of the sapling, so saplings X and Y, and the Z elevation will be the same. The next wood block I create, I'm just going to set the Z elevation up by 64. Next one I create up by 128. And I'm manually building a tree with every line of code. So I'm manually placing each one of these blocks where I want them to be. So this is just a lot of logic I've had to work out. And the way I've just done this is worked layer at a time. So I've worked with the first 4 layers of the tree trunk. I then put all my saplings around that 4th tree trunk, put my 5th tree trunk, then put all the saplings around that, and I've got my final tree trunk or final leaf at the top. So really, really simple code for that. Again, just a simple timer. When that time is finished, we create all the bits we need for a tree. And finally, the cobblestone generator, really, really, really simple sort of logic. Every second, it's going to pick the nearest cobblestone spawner, which is just actually a yellow block that I've got in Skyblock World. And as long as there's no cobblestone already in that position, it's just going to create a new one and set the Z elevation. So check if there's a block there. The moment you break it, so there's no longer a block there, it will create a new one. Only thing that's broken with this code at the moment is if you place a cobblestone on the same X and Y coordinates but on a different Z elevation, you actually break all this. There's some weird, strange stuff happening that won't let this code run if I enable this line of code. So I need to find out a different solution or find out exactly what's happening there, but that's how my cobblestone generator works. So before we look at the inventory and how that works, we need to look at the data tab because the data tab is really, really important. The data tab is made up of 3 different arrays, and these work as a small relational database. So we'll start with the block data first. Each block has a set of data that I want the game to know about. So we'll start off with a grass block. The grass block has an ID of 1. We then have the name of the block. So the block is called grass block. So I'm using this so if I use an item in my inventory, I can then pull this name to say if you've got a grass block icon, you want to place a grass block. We've got the drop name. So again, if I break a grass block, I want to get the drop of that and get that by name. And when I pick up that drop, I want to get the icon of that and place it in my inventory. So I'm using this to get all the items that I want and get the right versions. So as long as I've got the ID of 1, I can then get the block, the drop, or the icon. Final value of 1 is the time it takes to break. So you can see grass and dirt takes 1 second to break, cobblestone takes 3 seconds to break, wood blocks take 2 seconds to break. So I've got a lot of control of the game just in this one window. I've got this for every single block. Next thing we've got is our inventory. Now our inventory is actually empty at the moment. But if I wanted to add an item to my inventory, what I would do is I would go to the inventory data. I would set the value of X and Y. This is what I'm doing in the code when you pick up an item. I start by setting the X value access first. This can be set to 0 because I want the block ID I want to add to my inventory. The Y would be the slot in the inventory, which we'll talk about in just a second. I'm going to set this to slot number 3. And then the value would be the block I want to add. So cobblestone would be, or let's go wood would be ID of number 3. And this would add wood into my inventory. Second part of this would be adding the quantity. So again, I'm setting the X and Y and I'm doing this in the code so it's done for me. And I'm going to set the X to 1 because I'm dealing with quantity now. I want to deal with slot 3 because that's the slot I was dealing with before. And then the quantity, let's say I have 10. So this is actually what's happening behind the scenes when I want to add 10 wood to my inventory. Crafting recipes we'll talk about a little bit later. So let's have a look at the inventory first. So this is the inventory on the actual screen as the player sees it. And I'm going to start by hiding the inventory itself. So we're left with just the toolbar. Now the toolbar has an instance variable called slot number. So you'll see slot number equals 2. We've got 1, 2, 3, 4, 5, 6, 7, 8, and 9. And these slot numbers are really, really useful to tell me whereabouts in the inventory I need to place an item. If I load up the full inventory, you'll see I've got more of these red boxes, and these are invisible when you play the game. And again, we've got slot number 1, 2, all the way to 9. And then we carry on with 10, 11, 12. And this is what I'm using to work out where an item should go. If I pick up a new item, whereabouts am I placing it? And if I've got an item that I've already got, where am I adding 1 to the inventory? So this is the start of all of that. So let's go into the inventory now. So start off with this logic here that adds 1 to inventory. Now this takes in 3 parameters. First one's called item ID. So what item am I trying to add? So I am trying to add a dirt block, wood block, crafting table. So as I pick up an item, I'm passing the ID. Each one of these items that I've got on this list, so the grass block, leaf block, these will hold the ID. So as I break it, it will look up ID number 1 and place the right object in the inventory. I then got quantity. How many am I trying to add? Now, for normal block breaking, I'm only adding 1 at a time. For crafting, obviously there'll be situations where I might want to add more than 1 at a time, so that's why that option's there. And item found is checking if we found an item that already exists that we're adding to its current inventory quantity. So this is repeating 36 times. So there are 36 slots in my inventory, and I want to check every single one to see if there is an item there, and if there is, I'm just going to add 1 to the quantity. So if the item ID matches the inventory data, and I'm doing loop index plus 1 because the loop index, the current loop value starts at 0, all loops start from 0, however my slot numbers start from 1. So I'm going through every single slot 1 at a time, and the moment I find that item ID, I'm going to add 1 to the quantity, I'm going to reload the hotbar, and I'm going to say the item is true. If the item's true, I'm going to stop the loop. This stop loop didn't seem to work on its own, so I've added an extra clause here that changes that value and stops it again, just to be sure. Now, if we go through our whole inventory, we don't have that item already exists. Let's say that we pick up a sapling, we don't have any saplings in our inventory. Then we'll get to the end of that loop and we'll get to this value here. So the loop index now equals 36. No items been found. So what we're going to do instead is, first of all, I've got my debug text. The debug text will be off on the final version, but this is just a way that I can give myself some feedback to test my code. Main thing is I'm going to run this next function called next slot. And this is going to check for the next slot. So let's scroll down. Really, really similar than what we've had before. However, this is going to do 37 times. So I want to see what happens if we go beyond that. So if we get to 37, we've gone beyond our inventory, which means there's no more slots available. So first of all, I'm checking for any inventory slot that has that first item ID value set to 0. So the first one that has 0 as the ID, there's no 0 IDs, which means this must be an empty slot for us to put our item in. If we find an empty slot, all we're going to do is add the item and the quantity, just like I showed you when we looked at the data, and stop the loop. Bit of feedback to myself when I was testing this. And then we set item true. And again, this is just a bonus check just to make sure that loop is stopping and nothing else is happening. At the moment, I've got no sort of system in place to say we can't add this item to our inventory. All that will happen at the moment is the item will be destroyed and you won't have it in your inventory. So this is what happens if you pick up an item and your inventory is full. This does not check if you've got more than 64 in a stack. So this is something that will be implemented later on. So you can only have stacks of 64, but this does work for any item and puts it into the correct place. And it works pretty well, so I'm happy with that. So now we'll look at the function to load the hotbar. So the hotbar has a function that allows us to basically wipe all items and then start again. So the first thing we're going to do is destroy those items, and then we're going to start a loop. So it's going to repeat 9 times, and the main bit is this second bit here. We're going to check if any of these values do not equal 0. If any of these values don't equal 0, they must be an ID that we can place. So the same way we looked at our example here, we looked at this one, this would be item number 4, it's not 0, so this needs to be added to our hotbar. We're looking up our blocks table to work out which item this should be. So in this case, we're looking up slot 3 and whatever value we're getting from the inventory. So let's say we get the inventory value of 4, it would then look up item number 4, which would be a wood block, and then it would look at value 3, which would be wood block icon. It would add the wood block icon to our inventory. So we'd get this little icon symbol of a wood block appear in our inventory so we can see it. Now that works for our hotbar, but what happens if we open our full inventory? We're then going to create a loop that repeats 36 times for the 36 different slots, and if none of them are equal to 0, we're then going to create a block and look it up in our database. Now, when these items are created, we're then taking the second value from our inventory. So again, if we just go to our inventory checklist, we've got 10, and we're using that to set the quantity. So that's how we get our quantity, and we're just pinning that quantity to the item. So when we're dragging the item around, the quantity text stays with that item. So for our toolbar, if we use any of the number keys, we can jump around the different slots. And the way I'm just moving this little icon is just manually entering the pixels. So I moved this one at a time and wrote the pixels down. I tried to use maths to get this perfect, but I was off somewhere, so I just instead decided manually might be the quicker way. And then I set the current position to 1, 2, 3, 4, etc., etc. So I know which part of the inventory I'm looking at. Each time after, and you would have seen this function quite a lot, I call this select block function. This is a really, really important function because it tells us what block we are going to place down if we press the right click. This is what's happening here. It's just going to look up the block's data. So it's going to look up the ID, and it's doing this based off the inventory data and the current position we've provided. So to show you an example of this, it would look up this ID of 4, because this is where we currently are. We're looking at slot number 3, so we've got ID number 4. It would then look up ID number 4 in our table, which will give us a wood block. Next thing we've got is dragging items around the inventory. So what we've got is the moment that we start a drag and drop, we set the items X and Y position where they were last. We also add another clause to check where they were beforehand. So this would say, okay, you started at the coordinates 50, 50, and you're leaving slot number 3. Now, the moment that we drop, we're going to check if we're dropping somewhere that we can. If we're dropping somewhere randomly that's not on one of these red squares that I've allocated, we're just going to set the position back to where it was before. So if you've put it in a wrong place, let's say you've tried to put the items on the character's head or in the armor slot, it would just put those items back to where they were before. However, if you have put them in a different slot, what we're going to do is we're going to set the positions to the drop spot, which is what I'm calling those red squares, X and Y. This just means the item is lined up center instead of off to the side. And then we're going to change the inventory values. And all we're literally doing is copying the data from slot 3 into slot 7, and then we set slot 3 back to 0. So slot 3 now has a 0 value to say that that's been cleared. So that's how the inventory sort of works, and it is confusing, I'm not going to lie. It's not the easiest thing to set up, but hopefully it gives you a better idea. Final thing we're going to move on to then is crafting, and crafting has some issues, but the main part is quite simple compared to some of the other stuff we've looked at today. So I'm going to go back into the main Skyblock world, and if I put on this tab here, you'll see these green squares. Now these green squares have numbers on them, they have slot numbers, just like we've had with the inventory, and this is a way for me to tell which item is in which slot of the crafting table. Now these are numbers a little bit strange, because the first one here is 1, this next square below is 2, then 3, then 4. And this is so that all the logic that we use can work for these first 4 squares if the full inventory is not enabled. So if we've not clicked on the crafting table, this would be how much we get to see. If we do click on the crafting table, we get to see this much. The rest of the slots are named 5 and 6, and then 7, 8, and 9. So making crafting recipes can be a little bit confusing at times because you need to have yourself in this mindset of 1, 2, 3, 4, 5, 6, 7, 8, 9. But it's not too bad with having it on a bit of paper. We have a blue slot to say where the item is going to spawn at when we create that item. So first we're going to look at really quickly is actually putting this inventory on or off. This is just done by the E key, and it's done when you're not dragging an item, and this just solves a lot of issues where you're dragging an item and press E and then it doesn't save properly back to the inventory. And all we're doing is just making layers visible or invisible at this stage. When we come to the crafting, there's two things that we really need to know about. First of all, we need to work out if layer 5 is visible, and this only happens if you've right-clicked on a crafting table, and if not, we want all of our stuff to be on layer 4. So I'm moving those green squares either onto layer 5 or layer 4, depending on if I've clicked on a crafting table or not. Next, we've got this drag and drop. Now, currently in normal Minecraft, you click on an item and it sticks to your mouse, and then you can move it around, then you right click to place one or half a stack. Mine, I've gone for a slightly different approach, and this is something that might be reworked for my next build. So for the crafting table, we've got some different layers here. One is for the full crafting table, one is for the part one, and I'm making these visible, invisible based on when you clicked on the crafting table. Main thing is the drag and drop system. Now, normal Minecraft, you click and the stack moves with the mouse once you've clicked, and then you click again to place it down, or you right click to place half. I'm doing it where you can drag the block around, and this has actually been a bit of a mistake, I think, because crafting's become really difficult to place one item down. The solution I've come up for now, and this will probably change on the next build, is that you drag the item, and if you're holding the item for about a second, it will then place a copy of that icon onto the craft slot. Has some bugs, however, which is one of the reasons I think I might move away from it, but for now it works roughly as intended. So that's all what this bit's doing at the top here. It's just looking up the values to place it. So I'm looking at the block data again and looking at item number 3 to get the right icon. Then I'm calling this thing called check recipe. Now, before we look at the check recipe, the final thing we've got here is on a left click. So if you're clicking on an item that's overlapping the craft spot, all we're going to do is destroy that item. Now, every time that an item is placed or destroyed, we're changing this variable called stored ID. And this is on every single green block. So if we take one of these green blocks, you'll see that this has currently got the stored ID of 0. If I was to place my grass block on top, it would have the stored ID of 1, because the block ID of a dirt block is 1. If I was to place wood on there, which is one we've used a lot today, it would have the stored ID of 4. I'm using that system to do our crafting recipe check. If we left click on one of these, we want to put that back to 0 because the item is no longer there. So finally we come to our crafting recipes. Now before we look at this code and how this code works, we need to go back to the data tab. And on the data tab, we've got this crafting recipes. If I scroll down, these are the crafting recipes for a furnace, for a crafting table, and for planks. And you can see quite quickly that all of them are the same length. What I'm saying is what needs to be in each slot. So for crafting recipe 0, slot 1 has to be item number 3, slot 2 has to be item number 3. Number 3 is a cobblestone block if you've not guessed already. Slot 3, item 3, slot 4, item 0, slot 5, item 3, 6, item 3, etc, etc. The final value is what we get. We get item ID 7, which is our furnace. We'll look at one more. Crafting recipe 1, which is why all of these have the value 1. This be for crafting table. So first slot has to be 9, second slot 9, third slot 9, fourth slot 9. All the rest need to be 0. And then finally, wood planks, first slot 4, the rest 0. We get the item 9 back. You'll realize that we don't get what we call shapeless recipes from this. This is where you can place a plank anywhere and it'll give you that. If I wanted this, I'd have to repeat this 9 times. So no matter where I place my plank, it would still work. So that's how we do it from the erase side, but how do we then apply that to our code? Well, we know every green square holds one of those values, and all I'm doing is I'm looking if slot 1, if that stored ID equals the ID for slot 1 in any of the recipes, and I'm looping through all recipes right here, Then we check slot 2 and check if that stored ID equals item number 2 for any of them. And every single time I do this, I'm adding 1 to a recipe total. Now, in order for a recipe to be correct, all 9 parts need to be correct. So my final check at the bottom just checks if any of these recipes that we're looping through has a recipe total of 9. This number gets reset as we look through each recipe. So this will get reset 3 times because I've got 3 recipes. And if any equals 9, we're going to create a new item. And this would be whatever the final value is for the recipe. So again, we've got this one here, item number 9 would be wood planks. Finally, if we left click on the item that spawns, we can add that item to our inventory. We reload the inventory again. So again, that's deleting everything and putting the items back on. And that's it. We have our item that's been crafted. So there's a lot of code on here, and I apologize if some of it's not been made clearer, so I'm going to try and add some animations to make this a little bit clearer. But this gives you an idea about how the code was created for this project. The only thing we haven't talked about is movement. The movement code is a copy and paste from my 3D first-person movement tutorials, one for general movement, one for jumping and gravity. I actually started with that project and just built around it. So I'll leave those links in the description if you want to work out how to get the movement done. But this code will be available in the description if you want to have a look at it and do some more detail. If you've got any ideas on how I can improve my code, please send me an email with it or put it in the comments. I'd love to see it because this is a working project. I want to build this, I want to finish this up. So this is as close to the original Skyblock as we can possibly get. We can have a version of Minecraft in Construct with water, with lava, with farming, with tools. So thank you very much for watching. If you've enjoyed this video, please be sure to give it a like down below, subscribe to the channel, and join me for more Construct videos.